Hello, and welcome to our webinar today. My name is Patrick Murray. I'm a systems engineer with Veeam. I've been with Veeam about 3.5 years or so. And today we are going to talk about Hyper-V, kind of in an abstract sense, in a protection sense, in a security sense, right? But first and foremost, so upon joining, you were muted. So you don't have to worry about coughing into the microphone. But as such, that means you cannot ask audible questions. So I would ask that anything related to any questions you have about the presentation or about Veeam or about Hyper-V, I would ask that you go ahead and put those in the Q&A box. And then if you have problems like audio problems or video problems or problems with something else, go ahead and put that in the chat box. And then don't worry about like writing things down or taking screenshots, right? Because we will be posting both the recording and the presentation after the webinar, which is great because there are links and other things in here that you guys will want. So let's go ahead and get started. So what are we talking about today, right? So we're going to start by talking about building a secure data protection strategy, right? And kind of not directly related to Hyper-V, right? But when we're talking about protecting a Hyper-V infrastructure, really any infrastructure, step one is kind of the thought process behind that data protection strategy. Right? Then we'll get into more Hyper-V specific things, right? Best practices around Hyper-V from a security perspective, from a protection perspective. And then we'll go into backup and replication and how Veeam actually protects those workloads, some best practices around that, some considerations around that, and we'll take it from there. And then, like I said, at the end, we'll do questions. I'll try to save 5 minutes for questions or so at the end. So let's talk about it. Let's talk about the step one, right? So you have a Hyper-V environment and you want to protect it. Well, in order to do that, we need to talk about, like I said, the kind of the grander data protection scheme, right? So how do we go about doing that? Well, there's a few like pre-tenets we have to discuss first. Something about data protection is that it can be complicated. I feel often we see an oversimplification when we talk to our customers about data protection and how data protection is employed. Right? And what I mean by that are there are a lot of customers that are just protecting, grabbing all of their Hyper-V workloads and all of their physical servers and just running a nightly backup, right? And that's fine, right? You're backing up your data. You know that you can recover your data, but are you really protecting it in the manner that the business needs it to be protected, right? And what I mean by that is, so again, to continue with this example, let's say we run our backup nightly for all of our workloads at 10 p.m., right? That means that if we were to lose data, we were to have an outage or a disaster at 9:59 p.m., we would lose about 24 hours worth of data, right? And for a lot of workloads, that would probably be fine. But I'm sure in every single one of your environments, there are workloads that would not hit that threshold, right? So in order to determine what those workloads and applications that run our business are and to kind of determine what those recovery time objectives and recovery point objectives are for those workloads, we need to think about it. We need to talk about it, right? Talk about to the different business units inside of there, right? And if we don't, right, because of that, this ends up being kind of a linchpin for any business continuity or disaster recovery plans that we have for the organization, right? If we don't take into account how we're protecting data and what our threshold for restoring data is, it can have great detriment for the business. And then I would say that defining data protection or data protection in general is more important now than ever, right? For a couple of reasons. First and foremost is ransomware, right? Or ransomware-like attacks, right? Attacks perpetrated by malicious actors who are trying to compromise your systems for profit or for fun. If we have backups and those backups are secured, we can successfully mitigate that ransomware attack, right? Adding on to that, we have things like public cloud and software as service platforms where our data lives now, right? And I'd say that protecting that data, protecting those workloads that live up in the cloud is almost more important than protecting those workloads on premises, those Hyper-V workloads on premises. Because with the Hyper-V workloads, you at least still have control over that data, right? It resides in your data centers, most likely, versus software as a service platforms versus Azure or Amazon public clouds, where you've given up a degree of control over that data for availability, right? Protecting that data and bringing that data either back on premises or backing that data up to another location gives you a degree of control over it. Right. So how do we go about it? Well, there's no shortcuts to success, right? We kind of have to start at the beginning and build up a data protection strategy. So let's walk through it to make sure that when it comes time to restore, we don't end up like our friend the truck driver here, right? So if you are a Veeam customer or have seen a Veeam webinar before, you have probably seen the 3-2-1 rule, but we're going to dive deeper into it than you probably have before, right? So the 3-2-1 rule states, as you see it, that for any given data protection environment should consist of 3 copies of your data on with 2 different media, and 1 of them kept offsite, right? So let's dive into it. First question I always get when we start talking about this is, do I really need to have 3 backups? And the answer is no, you don't have to have 3 backups. 3 copies of your data means 1 production copy, or the copy that you're using every day, the data itself, and then your primary backup, right? Your backup that you're going to be using for short-term restores. The backup that you're going to be using to restore to prod for file level restoration, for VM level restoration, maybe a host dies or something like that, right? And you have to restore a number of virtual machines, but that's your primary backup. And then a copy of that backup, right? In case something happens to that first backup. We usually draw the line there. We usually don't see copies of copies of copies of copies. 3 is generally enough. And the question then becomes, why do we need a copy of that backup? And the answer is that backup storage is just as prone to failure as our production storage, right? So if we place our, if we only have a single copy of our backup, it's still sitting on spindles. It's still sitting probably at our production location because, again, we want it for fast restorations. So we need to ensure that we have a second copy of this backup data, right? And on top of that, right, kind of doing some quick maths, we can actually show kind of statistically how we can exponentially help mitigate data loss by just adding a single copy, right? So some abstract examples, but right, I still think they hold true. So let's say that any storage appliance, right, whether it's your primary storage appliance or it's your backup storage appliance, right, on a given day has a 1 in 100 chance of failure. So 1 in 100 times you walk into the office, you're going to have a problem, right? There's going to be a bad drive, there's going to be a bad controller, there's going to be a power outage, right? Some sort of failure. Just by taking your first backup and having it on a different array, right, a different location from your production storage, we're already able to mitigate that, right? That then becomes a 1 in 10,000 chance of catastrophic failure, which is still pretty good, If we add on another storage target, right, even if it's the same exact storage target as our primary backup, right, so just a third place where we have a copy of our backups. And again, assuming that that third target has the same 1 in 100 failure rate as everything else, we can help mitigate that to a 1 in 1 million chance of catastrophic failure, right? The chances of all 3 of those failing at the same time on the same day is very, very slim. So you could see how just statistically having a third copy or a third copy of your data, a second backup, can help not only with restoring, but compliance, peace of mind, so on and so forth. So 2 different types of media. Why? Well, don't keep backup data on your production storage, right? There's a couple reasons for this. The first should be obvious. If you are backing up to the place where your production data is, you're not really backing up at all, right? You're able to perform file level restores. You're able to restore data as long as that array is there. But if that array dies, everything is gone, right? All of your eggs are in one basket in that scenario. But, right, even if you're okay with that, primary storage, your SAN storage, is generally very expensive, right? Especially in the days of all flash arrays. You're paying a premium for that storage for performance, and it would be a waste to leverage that storage for something that doesn't require it, like backups, right? So keep backups on physically separate storage from your production data. Don't keep your second backups on your primary backup storage, right? It's same kind of basic tenant. Your backup storage is probably much cheaper than your production storage. It is worth spending money to get a second physical location or a second physical server for that secondary copy of the backups, right? That way, if one array fails, you don't lose all of your backups. So what does that look like, right? What do we consider acceptable secondary media? What is an acceptable second type of media for this? Tape. Tape is a great type of secondary media. I've actually seen a pretty serious resurgence of tape over the past year or so, especially with ransomware being a bigger problem, right? Tape is an offline copy of your backup. It's relatively dense with the latest LTO versions. And again, it's offline, so it's unransomwareable, right? We can't be ransomwared if our backups are written out to tape. Deduplication appliance, right? Still spinning disks, but connected over a different protocol than just say a Windows or Linux server. Dedupe appliance will give you better compression, better data reduction on that data that you're storing there. And again, we'll keep it logically separate. We generally recommend using deduplication appliances as secondary storage targets because for secondary storage, we're usually writing a lot of full backup files, right? A lot of weekly, a lot of monthly, a lot of annual backups. And all those backups contain a lot of the same data. So we can get some pretty good compression ratios and data reduction ratios out of deduplication appliances. Or the public cloud. Public or private cloud, right? So private would be, a co-location facility or dedicated hardware that you're leasing or renting from a data center provider. It could be a Veeam cloud and service provider that you're leveraging to use Cloud Connect backups. It could be the public cloud, whether it are just servers that you've spun up inside of Amazon or Azure, or whether you're leveraging object storage to tier off or archive off your backups from your production storage. Right, all of these are really, really solid secondary things and different types of media that we can put the second copy of backups on. And one of which offsite, right? And this is probably the most obvious reason why, right? But to break it down, regardless, we keep one offsite so that we can recover if the primary site is offline. Right? The primary site offline doesn't mean that we don't have to recover data. Maybe we have to recover data because the primary site is offline, right? Even if it's going to come back in a day or 48 hours or a week, we still need to be able to recover from that primary location, especially if that primary location doesn't exist. We can't count on backups that potentially won't exist anymore. Right, so keeping it off-site ensures that if something terrible were to happen to your primary site, you have a copy of backup somewhere that you can recover from. And then you have a copy that is both physically and logically separate. What I mean by physically and logically is physically because it's in a secondary location, but with backup copy jobs and backup and replication, right, we're able to configure different retention, longer-term retention on a backup copy job. So you may only need 30 days, maybe only 14 days of on-premises backup at your primary site, but you want 60 days of dailies and maybe 4 weeklies and 6 monthlies, 12 annuals, something along those lines, some longer, much more drawn-out retention at your secondary site, which we can do, right? And those backup chains, even though they're based on the same sets of data, will stay separate, right? Problems in one will not affect problems in another, right? If one gets encrypted, we don't write that encryption over to the target one in case of a ransomware attack, right? And speaking of, right, why are we focusing so much on data protection, right? Because what's the number one concern? I would imagine that if we were all sitting in a big sort of conference hall, and I asked you who thought ransomware would be the number one concern, almost everyone would raise their hand. Right? And you're not wrong. Ransomware is a very serious concern, right? It is a constant threat to IT environments today. But I would say that as people who are data protection minded, which of course we all are because we're on this Veeam webinar, the ransomware itself isn't really a huge concern. The huge concern for me, the really scary thought, is having no backups at all, is having the backups be compromised in some way, shape, or form, right? Having the backups be targeted specifically, having the backups be deleted, right? And that's why I think securing your backups, it should be the number one most important thing inside an environment, right? Because if you have backups that you can rely on that are essentially through, following everything we've talked about thus far, resilient, then ransomware is just going to be a temporary setback, right? It'll be on the level of a host failure. If all your data gets encrypted, but you have all your backups, you can just simply start restoring it, and it's like the ransomware attack never happened, right? So I say the backup environment and the backups are the most important thing to secure. And keeping in mind of this, right? Because, well, great, now I need to secure my backup environment. Where do I start? Well, just like with Veeam backup and replication, we're able to kind of use all of our tools, whether it's agents, whether it's O365 backup or Hyper-V integration, to kind of build a data protection solution that solves your problem, right? We're using those Veeam tools to solve for whatever problems you have. The same kind of thing goes for securing your backup environment, right? What problem are you trying to solve for? Are we protecting against ransomware? Great, then we should look into an offline backup. Are we protecting against potentially disgruntled employees, right? Then we have a different approach, right? Unfortunately, securing your data protection environment, just like securing any environment, isn't necessarily fun. It's not a romp in the park, right? Whenever we're securing anything, it means generally restricting access to individuals or to servers. So there can be growing pains around it, but again, this is the most important thing in most IT environments, right? And something to keep in mind is that when we're approaching this, we're playing our game of risk mitigation, right? Professor I had many years ago said, if you want to keep a system secure beyond any measure of doubt, disconnected from any network, right? If it's just sitting there running by itself, it's inherently secure. No one can come in and hack it. No one can exploit any vulnerabilities on it. But the second you hook it back up to a network, right, it's risk mitigation from there. So, maybe taking all of the steps we're going to talk about today, or all the steps that you may see in our best practices guide, may be a bit overkill. Again, it depends on what type of problem you're solving for and what kind of mitigation you're comfortable, what kind of mitigation you're willing to seek in a kind of a trade-off for taking on more risk, right? And so how do we do it? What are the basic principles of securing backups? Well, minimizing attack vectors. Right? Attackers, ransomware, they can only delete or encrypt or attack what they can get their hands on. So doing things like multi-factor, two-factor authentication, right? For example, I just walked a customer through kind of like locking down their Veeam environment because they were concerned of ransomware. So we removed the ability for anyone to use the backup and replication console on their laptops or their workstations. We installed a specific server that was only accessible from domain accounts from the admins that were going to be accessing the servers, and everyone had their own admin accounts here as well. And then we added multi-factor authentication on there. Right? No one's getting into that backup replication environment, like unless they are able to spoof multi-factor authentication, which usually just doesn't. It's a very difficult thing to do, right? It requires like a very complex man-in-the-middle attack. And then, because we're kind of thinking about security in the broader spectrum too, right? It's usually non-employed IT employees we have to be concerned about. I'm sure everyone on this webinar knows beyond a shadow of a doubt that if you get an email today, even if it's from me, and it says, hey, here's an invoice that was processed incorrectly, I need you to take a look at it, everyone knows not to click on it, right? But someone in accounting may not know that. And so someone in accounting may click on that attachment and open that, and malicious code gets executed, and now their account is compromised. And they find an unpatched exploit that allows them to escalate privilege, and now they have a domain admin account, right? And now they're in, and we don't know that they're in, and who knows where we can go from there, right? So a little bit of training, a little bit of gentle testing of your employees can go a really long way, right? A reminder that, hey, we're not going to send you any weird invoices ever. We're not going to ask for your password, those kind of things. Can't ransomware the public cloud or tape, right? Offline backups are the answer. Right, anything else is kind of mitigation. Offline backups are a solid way of mitigating that. I'm a bigger fan of the public cloud at this point in time, now that we support it natively, especially with version 10 coming out. We'll support S3's immutability functionality. means that if we check that immutability box on a bucket, I think they're called buckets in S3, no one can delete those files. Those files are undeletable. You can't delete them from the backup or replication console. You can't go into the S3 console and delete them. You can't delete that storage bucket, right? It is locked down for all intents and purposes. And unfortunately, right, I mentioned this before, but maybe the biggest threat is not external attackers. Maybe the biggest threat is an employee that's dissatisfied, right? And is, like I said, this not necessarily fun, but it may be worth considering this as a possible attack vector and having a more solid and stringent exit policy that you work with HR to prevent things like this from happening, right? Because we could have everything locked down to the nth degree, but if someone has access and decides they're going to go in and trash our backups, how do we stop that? Nothing that we've talked about so far is particularly easy, right? But that doesn't mean it can't be, right? So a customers generally ask me, well, great, multi-factor authentication, that's a pretty big investment. There's we're talking about HR policies, we're talking about security trainings. What can I do today that is going to help me mitigate ransomware? And I say, well, what is the majority of your hosts inside your data center, right? What is the most common operating system? And 99% of the time it's Windows, right? Especially with Hyper-V customers. They're mostly all Windows shops. So following that line, right, ransomware generally attacks the biggest footprint you have in your environment. It's mostly Windows-based attacks. So if we just take the step of deploying a Linux repository server as our second repository server, right? Maybe it's our offsite server that we're sending copies of backups to. Well, that Linux server isn't attached to the domain, most likely. So that account can't be compromised through phishing or something like that. And it's not a Windows server, so it can't be infected with a ransomware attack or a malware attack, right? Not saying that ransomware for Linux doesn't exist, but Windows is definitely much more common, right? So things to think about, right? I really can't stress enough how important I believe it is to not only like have a good data protection strategy, but have a good strategy for securing that environment. I talk about this with every single customer that I meet with now. I think it's very, very important. That being said, right, let's talk a little bit about Hyper-V. Well, let's move into talking about Hyper-V specific protection. So first things first, got to plug Hyper-V. I'm a big Hyper-V guy. I've been using Hyper-V as a hypervisor since 2012. Some things you can use to help your friends get acquainted with Hyper-V, come over to this side of the table. Everyone knows Windows, right? 99% of all the admins out there are going to know Windows. It's really just an app that runs on top of Windows. The GUI is nice. I think it's nicer than the vCenter GUI, and PowerShell I think is a much better automation utility than like the VMware Bash or VMware scripting console. And it's powerful and continues to improve, right? There's almost feature parity between, Hyper-V and vCenter. But if you look at where vCenter or Hyper-V has come from, right? If we take a look at Hyper-V 2012 and Hyper-V 2019, right? There's a night and day difference there, right? It is, for all intents and purposes, a production hypervisor, an enterprise production hypervisor. So let's talk about security for Hyper-V hosts, right? Locking down Hyper-V hosts. How can we do that? There's like 4 really easy things we can do here. Patches, right? Seems like a no-brainer, but your Hyper-V hosts or Windows hosts, they need to be patched too, right? Yes, that means downtime, but that downtime can prevent vulnerabilities from being exploited, right? That being said, we don't want to patch wantonly, right? We don't want to click automatically install all those patches on 4 p.m. on Patch Tuesday. That's probably a bad time to start kicking off. We don't want to update our BIOS at 10 a.m. on a Thursday, right? Like we want to schedule downtime for these. That being said, it behooves all of us who are Hyper-V admins to keep an eye on all of the Microsoft security alerts, because sometimes there are exploits that are critical and get released and need to be patched in a tighter time frame than once a month on Patch Tuesday. This is a really big one for me and something that often gets overlooked. So when you deploy ESXi in your environment, it is your production hypervisor, right? And what I mean by that is it's not used for anything else, right? Granted, ESXi does not have a GUI or command line operating system quite as robust as Hyper-V. It's more pared down, meant specifically to run ESXi. But regardless, we don't do anything on it. We don't put anything on the ESXi host besides virtual machines. I think that Hyper-V should be treated the same way, right? Unless you're using Hyper-V server, right? In which case there's really no way to do that. Right, you have a full Windows operating system, and in my opinion, that's one of the strengths of Hyper-V is that you have this operating system you can move around in. It gives you more mobility, but that doesn't mean that you should be hanging file shares off of those Hyper-V servers, or running maybe half the resources with virtual machines and then throwing a SQL server on your Hyper-V server, right? This goes against what we just talked about in terms of minimizing your attack vectors, but also minimizing the resource utilization, right? That is available for new virtual machines. I can't stress this enough. Like, let your production hypervisors be your production hypervisors. And then role-based access control. So first and foremost, no one should be logging into the hypervisors who shouldn't be logging into the hypervisors, right? We don't want, I don't want developers logging into my hypervisors. I don't want, in some situations, maybe I don't want the junior admins logging into the hypervisors. So there should be role-based access control via either group policy, via local security groups, via domain groups, so on and so forth, and strong passwords, right? If you have MFA, you should probably put MFA on these servers, for sure. Let's talk about protection, right? And I'm not talking, we're not quite at backup yet. Backup's the next section for how Veeam is protecting these workloads that sit on top of Hyper-V. I'm more so like the native tools at our disposal, right? What native tools are inside of Hyper-V that we can leverage to quote unquote protect virtual machines or protect our data? Checkpoints, right? Checkpoints are great. If you don't know what a checkpoint is, it works much like a snapshot. It's basically Microsoft's version of that. So if you, for example, let's say you wanted to test some patches. You can take a checkpoint for a virtual machine, go into that virtual machine, kick off the patch job. Maybe it runs successfully, great. You can go ahead and commit that checkpoint. So now that's the new running state of that virtual machine. Maybe the patches fail catastrophically, right? Maybe you install this patch and the VM starts blue screening. Well, that's really bad. We don't want that. So if that's the case, you can simply just delete that checkpoint and we'll revert to the state we were at before we took that checkpoint, right? Very powerful tool. We use them for backups. Veeam uses them for backups, definitely. But checkpoints are definitely not backups in and of themselves, right? They are good for one-off things like I just described, but you cannot take checkpoints and say restore files from them or restore application data from them. You can't take those checkpoints off of the Hyper-V server and put them on, a Windows server for safekeeping, or send them to the cloud or something like that. Right? It doesn't quite work like that. So it's not true protection. It's a tool, not protection. Hyper-V replication, another great built-in tool for getting workloads from Hyper-V server A to Hyper-V server B. This is very useful if you have workloads that have a recovery time objective that would not allow you to recover from backups, right? Whenever you're recovering, you're basically attacking a physics problem. Right? You're going to have a max throughput from where you're reading backups from to where you're writing backups to, right? All other things equal, maxing out everything, right? That's still going to take a fixed amount of time. And if that fixed amount of time is outside of your threshold for the business, then we need to look at another solution. And replication can be a great tool for that. Rather than restoring from a backup, we're simply failing over or powering on that replicated virtual machine that is sitting on another host or cluster, right? But replication is not a DR plan. And this is true even for using Veeam replication. Replication is not a DR plan. It is a method for failing over, and I cannot stress that enough. What I mean by that is that, let's say you've got your virtual machines replicated, right, to your secondary site, and something terrible happens. Your primary site goes down, there's construction outside, they cut the whole fiber bundle, or they cut a power cable, right? And you need to fail over to your secondary site, fail over to these replicas. If you haven't tested this and it's not part of a plan, there's no way of knowing how the network is going to respond, right? Is it the same network on that side? Do you need to do manual network changes? Can those network changes be scripted? How about DNS? How is DNS going to respond to those servers just being powered on at the other side, right? Will they be reachable? Will DNS get updated if you do have to update the network addresses? And how about access, right? If you have remote workers, do you have networking configured so those remote workers can continue to access those workloads on the secondary site, right? So there's a lot of asterisks next to we have a replica, right? We have a failover plan. Really what you have is a methodology for failing over, but you still need to do the legwork inside of your business to determine kind of how you're going to use that tool and in what capacity you're going to use that tool. And I add this one in just because every time I talk about Hyper-V, I have to mention it. I did have a customer tell me that they were doing this. They had a script that was taking checkpoints of their VMs and robocopying the VHDXs on the back end to another storage location. It is not backups. I suppose in some crazy, bizarre world, you could call it backups, but I would never refer to it as such. It's not a reliable solution. Right? And so, right, what we've determined is that Hyper-V has no real native methodologies for protecting our data, right? There are methods for maintaining that data. We can cluster our Hyper-V servers together to make that data highly available, right? But essentially, it's not that different from the public cloud in that the hypervisor does no native protection. The shared responsibility is on us, the users of that data, to protect it. So there's a lot of considerations when you're choosing a data protection platform, right? And presumably everyone here is either seriously considering or has chosen Veeam as that platform. But these are serious points that you need to consider, right? Because there's a lot of different things here. Agent versus agentless, right? Native integration with Hyper-V, does it leverage resilient change tracking, which we'll talk about in a bit? Is it just backup? Is it just replication? Right? These are all questions you have to ask when you're looking at data protection solutions. And ultimately, the best one, and I assure you it's not just going to be a big Veeam logo that pops up on the screen, because that's the best solution. The best solution fits your budget, right? Everyone wants a Ferrari, but Ferrari is not in the budget for most people that I know, right? We have to be practical about how we're approaching this. This one's important to me. This one kind of hits home. Because of my experience before Veeam, where I was still actually using Veeam. But protects what you want, how you want it protected, right? So before I came on board at Veeam, we were using a data protection solution that was not Veeam, where the methodology for restoring any application data, right? So let's say Exchange, for example. We needed to restore an Exchange set of messages. Our methodology for that restoration was to spin up a domain controller in a segregated environment, to spin up a bare metal restoration of the Exchange server, the passive DAG that was taking copies of all of the mailbox databases, spin all of those up, load all of those databases, connect into those databases, and pull messages out via Outlook, right? It's not a tenable solution. We were taking backups, but we weren't protecting things how we wanted it to be protected. So it's important to make sure that you can restore data in the manner that you want to restore data. Obviously, it has to natively integrate with Hyper-V. That's why we're all here, right? Because it's the best hypervisor around. And this is probably actually the most important, is helps you hit your RTPO, right? If it checks all three of those other boxes and it meets all your other needs, but you're not able to restore those critical workloads within 15 minutes, or it's going to take 2 hours too long to restore the entirety of your environment if it fails, then it's not the right solution for you. It's just not. Right? And there are some tough decisions that may have to be made around that. So now that we've all decided on backup of replication to protect our Hyper-V workloads, let's talk about how we do it, right? And in this scenario, it's no secret that Veeam is synonymous with VMware. That's kind of how we got our start. Hyper-V wasn't added as a hypervisor that Veeam supported natively until 2013. Right. And so the question is always, well, how do backups differ between Hyper-V and VMware? And you could really answer in a single word, which is to say proxies. right? Like we talked about before, this is a situation where we get to use the fact that Windows is an actual operating system to our advantage, right? ESXi has no operating system, so we can't install anything on it, which means that all the components we need to interact with it to move data, to back data up from it, have to be external. We have to spin those components up, usually inside of the environment. With Hyper-V, we have an OS to work with, so we don't necessarily have to do that. The second question I always get is, when is Veeam going to add storage integration to Hyper-V, which we'll get to in a minute. In ESXi, there are many transport modes. We call them transport modes. So there's virtual appliance, there's direct SAN and direct NFS and network mode. There's all these different modes. With Hyper-V, you've just got two. It's much simpler. You've got on-host and you've got off-host. They are relatively self-explanatory. They do exactly what they purport themselves to do. On-host backup means that the hypervisor, the Hyper-V server where your VMs are, is going to be used to back up those VMs, right? It's going to leverage its resources, its CPU and memory, to read that data and send it to the repository, which is where we're storing data. Off-host is going to leverage a secondary or tertiary, in some situations, Hyper-V server to offload that processing, right? So instead of processing it on the host on-host where the VMs reside, we're going to process it off-host on a secondary or tertiary server, right? And we're going to go into the main differences between this, because I think this is the most important thing when we're protecting Hyper-V workloads. So considerations for the on-host, right? This is the default setting. When you add a server, it will automatically be the proxy for all of the VMs on itself, right? Any VMs that are sitting on this Hyper-V server will be backed up by this on-host proxy. If you are not using a SAN, right? So even if you have a cluster and you have local attached storage or direct attached storage, this is your only option, right? So this is generally seen in like remote sites at standalone hosts. But you cannot use an off-host proxy for reasons we'll talk about later, unless there is a SAN configuration on the back end, right? And probably the most important point about on-host is to make sure that you have enough resources, right? This is a point that I'm going to hammer home because it gets lost many, many times. And it's important because, again, we're talking about production hypervisors here. So this is the wizard part of the wizard screen when you add a Hyper-V host into backup and replication. Existing customers will recognize this screen. If you are not familiar with backup replication, this is the entirety of it, right? It is very simple to add a Hyper-V server. In this scenario, we've already specified our IP address or DNS name. We've specified what type of server it is. Is it a standalone? Is it a cluster? Or is it part of an SCVMM installation? We've specified credentials. We've authenticated to it, right? Now we're at the last screen. And the last screen gives you a very, very important piece of information that is often overlooked, which is this Hyper-V server will act as the backup proxy for jobs running in the on-host backup mode, right? It is telling you right there, this is exactly, I am going to use myself, or I'm going to use this server to back up the VMs that live on this server. And then below it, it has that task limit. That task limit is how many concurrent virtual disks we can protect at once, right? So 4 means we're going to process 4 VHDXs simultaneously, right? So to give you an example of how that works, right? We process everything in parallel. So let's say you're backing up a remote office and it's a small host that has 6 virtual machines on it, right? So you have this host configured for 4 tasks. That means VMDK or VHDX 1 through 4 will get processed immediately, right? And then as soon as the first one is done being processed, VHDX 5 gets slotted in there and then gets processed, right? And then so on for VHD6. The reason this is so important, and the reason I stress this so much, is because the number of tasks that you have configured corresponds to a recommended hardware, recommended resources, right? So each one of those tasks needs, or rather we recommend via best practices, 1 core and 2 gigs of RAM per task, right? So in this specific scenario, we would want at least 4 cores and 8 gigs of RAM of overhead, right? So that's resources not being utilized by the operating system, resources not being utilized by virtual machines, and certainly not being utilized by, say, SMB3 service or a SQL server, so on and so forth, right? So very, very important that you are not overcommitting your Hyper-V servers. And then kind of what the traffic flow looks like, right? So we start up in the top left at the backup server when we kick off a backup job. The backup server doesn't really do any heavy lifting in this scenario. It just kind of is the command and control interface. So it's telling all the components what to do. We'll move slightly down to the right there. So you see we have a data mover service running on the Hyper-V. That is what happens. If we take a look here, we see the Hyper-V integration service. That is what that data mover service is. So that reads VMDKs, VHDXs, processes all that data, and then sends that data to the backup repository, right? So pretty straightforward. Let's talk about off-host. So there are a lot of requirements for off-host proxies, right? So the first is that it has to be the same version of Hyper-V as the rest of your environment that you're protecting, right? And what I mean by this is if you have mixed clusters, so you have a 2016 cluster, a 2019 cluster, and maybe a couple of old 2012 R2 hosts, and you want to use off-host proxies for all of them, you're going to need at least one 2012 host, you're going to need at least one 2016 host, and you're going to need at least one 2019 host, right? Any off-host proxy that's being used for Hyper-V backup must match the version that it is backing up from. It must not be a part of the same cluster. It has to sit outside of the cluster. So you cannot take a server, if you were backing up a 3-node cluster, you cannot take server 3 in that cluster and use it as an off-host proxy. It has to be a 4th server not as a member of the cluster. It is very strongly recommended that that server be a physical server. I have in parentheses VMware VM. Generally, customers are hesitant about pulling the trigger on a physical server to act as their Hyper-V proxy. So they try it with a nested VMware virtual machine to see how it works for them. That being said, that is not generally a supported configuration, especially because we need LUN level access to the LUNs that are being presented to the production Hyper-V servers. And we need access to them on the server over the same fabric that it's being presented to in production, right? So if you're presenting if you're presenting LUNs over iSCSI, we need this off-host proxy to be on that iSCSI network with the same ACL level access as the rest of the hosts. If this is fiber channel, we're going to need an HBA, fiber channel HBA inside that server that's zoned correctly for these LUNs as well. Right? And then lastly, the non-Veeam piece that we require is a hardware VSS provider. Right? And the hardware VSS provider helps us manage moving that data over to the off-host proxy so that it can be read, right? And what this looks like is very similar to how we had, very similar to an on-host backup, except there's an additional thing here, right? You see now there's the off-host backup proxy with a data mover service. So what technically happens here is we use that hardware VSS provider. And I say that's a non-Veeam component because it's coming from your SAN vendor. But if you have a pure SAN in-house, you're going to need to go to the Pure website and get their hardware VSS provider. Sometimes, like EMC, I think is on the actual SAN itself. The SAN vendor provides this essentially. But what it allows us to do is essentially trigger that snapshot on the LUN, allowing us to move that LUN over to our off-host backup proxy, where then the off-host backup proxy can read all of that data, right? It then reads all the data and writes that data into the backup repository, right? The benefit of this, the benefit of all this configuration is that that source host, that production Hyper-V server doesn't have to spend any resources running backup, right? So the question comes down to, is the juice worth the squeeze in this scenario for the hardware investment and for the time investment? And the answer is maybe, right? It really depends on your environment. I will say that I see many, many more on-host configurations than I do off-host configurations. So backup modes. These are Hyper-V specific. There's really 3 modes of backup that are available, right? Online is the recommended way to do it, right? This is your Veeam application-aware processing enabled backup. There's no downtime here. The VMs keeps running without interruption. This is leveraging our integration with Hyper-V and is actually touching the virtual machine, is taking VSS snapshots, is reading and backing up application data, but also just making sure that your backups are application consistent, right? If a backup is application consistent and you go to restore it, it behaves as though it were restarted, as opposed to crash consistent, which behaves as though the power was plugged on that virtual machine or that machine, right? So an offline backup is kind of a native Hyper-V quiescent backup, where we won't leverage any Veeam integration. It will get a application consistent backup, but the VM, there is downtime involved, right? The VM will be forced into hibernation in order for us to create a stable image. So probably not a tenable solution for most customers out there. And then finally, we come to crash consistent. So crash consistent essentially means we're just talking to the hypervisor, right? There's no integration, there's no quiescence. We're just talking to the hypervisor and saying, give us backups of this VHDX and the corresponding configuration files. And the Hyper-V server says, yes, okay. Right, so no VSS interaction there, no actual network level or authentication against the virtual machine, thus no application consistency. Again, offline backups, definitely the way to go if you can. And if you can't, we'll talk about it in a second, a way that you can do that. So shielded virtual machines, right? I don't know a lot of customers that are running shielded virtual machines or BitLockered machines, but it is worth talking about because there are some out there. A shielded VM essentially is like a host level encrypted virtual machine, right? And as such, we can't, right? We're not going to be able to touch the actual network there. So it's going to be a crash consistent backup every time because we're just going to talk to the hypervisor. Because they're locked down in the way they are, we're going to have reduced restoration capabilities for files and app data. That means that we're not going to be able to do file level restores back into the server where it initially came from. We're not going to be able to do application level restores like SQL, Exchange, Active Directory back, excuse me, back into production because that environment's locked down. And because it's locked down, they have to be restored to the source host guardian server, right? They can't be restored to another Hyper-V server. So steps must be taken, perhaps with like a Veeam agent or something along those lines, to secure that host guardian server, right? So that we can restore that server and then restore the VMs on top of it, right? BitLocker is not supported for Shield VMs. If you have BitLockered virtual machines, it is mostly, it is just the second bullet point that applies here, right? So if it's BitLockered, that means that when it is off, the drives are encrypted. So we're not able to mount that virtual machine. We're not able to mount that backup and pull files or applications out of it, right? The method for doing that, the workaround for that is actually to use an instant VM recovery. That'll bring the virtual machine up and running. That way the BitLocker volumes can be decrypted and then files can be moved in kind of live over from that server to the other server. So kind of good to know, I would imagine, especially if you're running with shielded servers. So we're nearing the end, probably a couple more minutes, then we'll start taking questions. This is things that I've built up over the years, what I like to call my rapid fire tips and best practices, right? Just kind of Veeam and Hyper-V specific things that I have found helpful. I always put the proxy stuff up here, right? The proxy sizing is one of the most important things. 1 core, 2 gigs of RAM per VHDX, you want a proxy protecting, right? Each one of those tasks needs to have those resources available to it. Change block tracking, right? So in 2012 R2, Microsoft did not have any change block tracking for Hyper-V. And to take a step back, right? Before I tell you how we solved that problem, if you don't have change block tracking, that means that there's no cognizance of what needs to be backed up for that day because we haven't kept a tally of what's been backed up prior. So to protect a workload without change block tracking, it would require us to read the entirety of the disk every time, essentially, right? Perform a complete digest and then compare it to our blocks. 2012 R2, we had our own change block tracking driver that we injected. So if you're backing up Hyper-V hosts currently and you have a 2012 R2 environment, you are using our change block tracking drivers. 2016 and up, Microsoft came out with their own change block tracking called Resilient Change Tracking. which we now fully support. The caveat here is if for some reason you are considering or have a 2012 R2 environment where the storage is presented over SMB, so specifically, this was a problem or an issue in tin tree environments. Well, the tin tree SMB shares are not lettered volumes inside of Disk Manager. So Veeam had no way of injecting our change block tracking driver into those volumes. And so we ended up doing full digests each time. Right, so something to consider there. Not a problem on 2016 and up, definitely a problem on 2012 R2. PowerShell Direct. So PowerShell Direct is a neat little utility that you can use if you want application consistent backups, but can't allow Veeam to talk to the VMs over the network, right, directly. Maybe we don't want to give Veeam credentials to those virtual machines. Maybe we don't want network level access from the backup environment directly to the VM network, right? We just want it to stay on the management network that the Hyper-V hosts are on. If that's the case, and we have 2016 hosts with 2016 or Windows 10 and greater VMs, we can use PowerShell Direct to get those application consistent backups, even if the network is locked out. If you're running Linux virtual machines on your Hyper-V, most customers do not know that the built-in Linux integration is okay, but is prone to failure. And if it does fail, Microsoft actually has a backup set of Linux integration tools. There's a blog linked on that on the second page of this. And finally, my misspelled last bullet point is supposed to read IVMR for instant VM recovery of Veeam agents, right? So you can take Veeam agents are a product, another product that we have that we use for physical servers. We use them to protect workstations. We can use them to protect cloud workloads as well. With Veeam Backup Replication, we could take any workload that we've protected with an agent, and we can do an instant VM recovery into a Hyper-V environment. This means that you have a recovery path, an instant recovery path for all of those workloads. This means that you have a conversion path for some of those workloads, right? If you bring say you're backing up AWS workloads in the public cloud, and you're like, hey, actually, you know what? It's getting too expensive to run these. We need to pull a copy of them back down. You can throw an agent on that workload up in the cloud, back it up, bring that backup back on premises, do an instant VM recovery to your Hyper-V server. Now that workload is up and running. And then while it's running, do what we call a production migration to take that workload from running off of the backup to actually creating a new VHDX, right, to being a production virtual machine on production storage. Some helpful links. Again, this presentation and the recording will be available on our website after this. Would recommend checking these out kind of in order of importance, right? The best practices guide, if you have not read through it, it is worth reading through cover to cover. But more specifically, a lot of the ideas for the security pieces that we've talked about in this presentation are pulled directly from the best practices guide, right? A lot of people smarter than me helped to put that together, and it's definitely worth your time. Administrator guide. Wonderful. Even if you're familiar with Veeam, you've been using it for a while, take a look at the administrator guide. Anything that you can do via the interface is documented step-by-step in that guide. I always have it open in a tab when I'm working with a customer, working in my lab, etc. Two sizing calculators, repository sizing, proxy sizing. Can kind of, those two will take inputs that you give them. So I have this much data, I want to keep it for this long, and spit out, this is how much space you'll need to do that. Likewise with the proxy calculator, I have this many VMs and this much data. It'll say, this is how long it's going to take you, and this is how many proxy tasks you'll need to do it in that long a time. There's that Linux Integration Services Microsoft blog, and then a place to download our free Veeam agent. If you haven't used our agent before, it's worth checking out. It is free. I do use it to back up my laptop at home, my girlfriend's laptop, so on and so forth. And finally, before we move to questions, I got to give a plug to our Veeam on Virtual, which happened late last year, but it is the premier virtual conference where we brought the latest and greatest in data protection and security and management directly to you. So you could find, if you take a look at this, it's all free. You can find the content that'll keep you on top of the new innovations, tools, and techniques that you need for your business, for data protection, for a hybrid cloud strategy, for leveraging software as a service, right? So on and so forth. And with that, let's take some questions. Okay. So first question is, have we seen, Oh, I'm actually going to scroll up because we've got a lot of them. Okay, first question. Do I prefer reverse incremental or incremental? That is a great question. I prefer incremental really quickly. Why? Reverse incremental is a 3x read write, whereas regular incremental is a 1x write, right? So when we think about what we're doing on a daily basis, right? Assume that we've already taken our full backup, right? So we're on day 4 of our chain. If I have 2 backup jobs backing up the exact same amount of time, right? I run the incremental job, it will grab the changes for the day and write them into a VIB file, right? A Veeam incremental backup file. And that's it, the process is done. On day 4 of a reverse incremental file, I will need to write those incremental changes. I will need to read the data from yesterday's, and then I will need to write that data into an RIB file, or reverse incremental backup file, or a VRB, Veeam reverse incremental backup file, right? Reverse incremental does have the benefit of being able to restore from the latest full without opening any other files. But I feel like unless you're doing a lot of restores and time is truly of the essence, you're gonna like run out that welcome very quickly, right? I always tell my customers to try to move and focus on forward incremental. Okay, yes, the slides and webinar will be provided to the attendees. Should I keep the Veeam server off the domain? That's a good one. That's a good question, and it's one that I talk about a lot. The Veeam server can be off the domain, right? Because when you're thinking about what kind of access you actually require to the Veeam server, it's not much, right? It's essentially console level access. So having the server on the domain really just means it's not going to be subject to security policies that you have on the network, right? You'd have to patch it manually if you have like a WSUS server, but I mean, you're still able to specify domain credentials for all the hosts that you're protecting, right? For your workloads that you're protecting, so you can get those application-aware backups still. I don't have a problem with removing the Veeam server from the domain. I've seen a lot of customers do that, and I can I see it as a viable option. Okay. I have good Veeam backups of my Hyper-V machines on a NAS. Can I copy those to another media, take them off-site, and consider that a safe strategy? Yeah, there are more automated ways to do that, like using a backup copy job. But yeah, I mean, that's definitely a way to do it. Are you aware of similar functionality as S3 immutability in Azure? Yes, we are aware of it. It is simply not going to make it in time for version 10, which goes GA in 2 weeks. So adding the immutability feature on Azure, as well as our S3 compatible partners, right? So we also integrate with any S3 compatible solution, something like a Wasabi, a Cloudian, a Minio, a Scality. We'll eventually add that immutability function to all the object storages that we support. Does the tape backup module in Veeam require the tape device to run on only Windows? Yes, it does. A tape server in Veeam backup replication has to be a Windows server, and the tape server has to be physically connected to that Windows server. We do not really support pass-through tape appliances, even if it's over iSCSI. Oh man, all right. There's a lot of questions about REFS, and we're running down time, so I'm going to answer that REFS question. So REFS question, I at this point recommend customers use REFS if they're using Windows repositories. It's kind of the Veeam best practice at this point. In fact, if you go to add a Windows repository as NTFS, Veeam will yell at you. And Veeam will say, hey, you're adding a repository that is not REFS formatted with 64K blocks. Are you sure you want to proceed? It saves a lot of time on things like merge operations, on things like synthetic full operations. It can save a lot of space on things like synthetic fulls. Synthetic fulls are also how we create GFS points on our backup copy jobs. So at this juncture, I do generally recommend using REFS. I have seen more people using REFS repositories as well. Let's see if we've got one more one. How does Veeam deal with swapping hard drives for DR? We actually have, that's a great question to end on. we have a function. If you go into your repositories and you right-click on your repository and you click properties, there is a box you can check that says this repository uses swapping hard drives. And so what it'll do is it will look for copies. It basically tells Veeam, hey, there may or may not be the backup files you're looking for here when you go to perform a backup, right? And so then Veeam will just continue the backup chain on those drives without freaking out and saying, hey, I don't have these backup files, right? And there are so many other questions. I'm sorry. 64K blocks for REFS. There, I see as I'm scrolling down. I'm seeing a lot of questions around the 64K blocks. We recommend 64K blocks. That is our best practice. We have seen problems with 4K blocks. And with that, I will thank you all for your time. If you have more questions, please go visit our forums, forums.veeam.com. Myself and all of the rest of our engineers and product strategy teams are on our forums and can help answer those questions. Yeah, again, thank you all for your time and have a great rest of your day. Take care.